How to define the goals of your computer vision project. In this video here, we're basically going to answer that question. We're going to go step by step how you set up a computer vision project, each individual step, how to set up your goals, data, training, inference, and basically how to apply business use cases on top of that. So if we go inside the Ultralytics documentation, we can go inside the resource tab, documentation, and we will open it up. Right now we have a ton of different guides. You can go through them. We have videos for most of them, so definitely check them out here on the YouTube. And if we scroll a bit further down, we can see we both have like all different types, like steps of computer vision project, data collection, annotation, tips for model training, how you do evaluation, fine tuning, and so on. In this video here, we're going to see how we can define computer vision project goals. So a practical guide for defining your computer vision project. First of all, when we want to solve a problem, we need to do first principle thinkings, boil down the project. Don't just get started on it before act like sitting down and thinking about it. You'll save a lot of time, but also you'll get significantly better results. So it doesn't matter what problem you're trying to solve, computer vision, all different types of AI or software problems, we need to sit down and define our problem statement. So first of all, as you can see here, we need to identify the core issues, determine the scope, consider end users and stakeholders, because at the end of the day, we're building systems that we need to use either by someone else or in a production setting where it needs to run automatically and so on. So we need to take our end users and also the product, the deployment into account. Then we can analyze project requirements and constraints and so on. So what is the time, budget, personnel, and identify like different technical or regulatory constraints. We need to take this into account to start with so we can plan out the goals, but also the steps that we need to take. Define the boundaries of your projects, pinpoint specific challenges in your computer vision projects. Is it on the data side? Is it on the model side? The business use case or the logic that we want to apply on top of the outputs from a model, or is it act like this software system around our AI models? So here we have a pretty good example where we just walk through how we can estimate the speed of vehicles. Could be any road, could be any system, could be traffic monitoring, could be in a production system where we want to do tracking, counting in specific regions, could be applied to all different types of computer vision use cases. But first of all, we need to go in and basically just come up with the requirements. How do we solve it? What are the limitations and what technical issues could we run into? But even more important as well is just what frameworks, how do we get it up and running as fast as possible? How can we do iterations? But also what tools do we need to start out with? So for example, this one here, if you want to do speed estimation, we need to know, or we basically know that we need to do object detection. We also need to do object tracking because we need to track vehicles and objects over time in a video sequence and not just on an individual image. Could be other use cases where you just want to take a snapshot. You want to maybe do some OCR, detect different objects. If an object is present in an image, we want to raise an alert or do something that can just work on a single image. Then we don't need object tracking. But for speed estimation, we need to have object tracking, track objects over time, because when we have that into account, we know how far the vehicles have traveled. We get number of frames, so we have the number of frames per second. So we have the distance, we have the velocity, or we basically have the speed, and then we can calculate the velocity. So you need to boil down these different tasks when you go in and solve a business use case. We're dealing with cars, so it's pretty easy to go in and detect cars in a video or like in images. We have the base models with Ultralytics directly available out of the box that will detect all different types of vehicles, trucks, buses, cars, whatever. So we probably don't have to go in and fine tune a model specifically for that, at least for setting up our business problem. Then we can iterate, evaluate models later on, start generating a data set, and then improve the accuracy. But just for getting the system up and running, we don't really need to go in and deal too much with data. It's more taking the results, doing inference, and applying the business logic around it. So this is a very good example. We also need to have this trap line, where if these tracks, we can see there's a trail behind each individual object that we're tracking. So this is how it's moving from frame to frame over time. And if that line crosses this line here, we can either do object counting, so how many cars are going in and out, but it can also be used for speed estimation, where we have references that we know, okay, this distance here between these two lines, when we cross this, we can use the time information to calculate the speed, or at least the estimated, but also acceleration. Then we can set measurable objectives, so accuracy, we need to deal with accuracy, processing real-time video feed, so how fast do we actually need our system to run for the specific problem with speed estimation. The higher frames per second we have, the more accuracy we'll get as well on the speed estimation, not necessarily on the object detection. We could get that where we go with 60 frames per second camera instead of a 30 frames per second camera, just because we can get better detections, less blur when we capture images at a higher rate, but also just to get more information how our vehicles and objects are moving from frame to frame for our analysis with time. This could also be in a production setting where objects on a conveyor belt or in other projects or production systems is just running so fast that we won't be able to see anything at 30 frames per second. And also, if you need a GPU, CPU, and so on, we need to scope that out, because if we have a real-time system running, we can process frames at a few frames per second. That will not be suitable. Then the connection between the problem statement and the computer vision task. So here, for example, we know that we need to do object tracking. We can also just do object detection and so on, but it is not enough when we need to calculate the velocity, or basically the speed of the cars. Most applications, they might require object tracking on top of it. You can just run it with Ultralytics. Instead of just calling .predict, you call .track, and it will do object tracking as well. We already covered the model selection, data preparation, and also model training approach, but could be other examples. For example, if you're using want to solve medical problems, you might want to focus way more on the dataset, because it's not too much public available, but most of the advantages will come from your dataset, improving that. We don't have any base models directly out of the box, so then you will probably start with data preparation, then do model selection, do some evaluations, train your models, and then have that flywheel where if we can use a model out of the box, we might start with model selection, get into inference, and then we can start build out a dataset and do model training. So this is pretty cool, and this is how we define the project goals for a computer vision project, but we need to set up some metrics, how we can measure it as well, do model evaluation, keep improving it, so we have this data flywheel pretty much, or whole computer vision workflow where we have our data, train, evaluation, and then we basically just feed that back in a loop to keep improving our system. After we've done, when we run inference, we also need to scope out the goals for how do we run these models. We already talked about that a bit for the practical use case, but edge devices, do we need to run the frames real time as fast as possible, no latency, or like close to no latency at all? Do we want to do on-prem deployment, cloud deployment? We'll introduce some latency, sending images back and forth from the cloud provider as well. Do we want a hybrid solution? It really depends on your use cases. Sometimes we just want to do inference on a few images. We can do a cloud server, just send a request, get a response back. Other examples, we need to run our applications in real time, needs to happen on the edge. No matter what you're going with, it's pretty easy to get up and running with Ultralytics. Spin it up, use it. We have examples pretty much covering all of it, so make sure that you check it out. But here, it's much more about applying the business logic on top of it, use the correct tools from Ultralytics, build software systems around it, get to the project goals, set up the whole pipeline, and start solve business use cases. Hope you learned a ton this video here. This is very important to scope out the project goals in computer vision systems. It's not only specifically for computer vision system, but pretty much any software, AI, machine learning system out there. Hope to see you guys in one of the upcoming videos. Until then, happy learning.